In today's lesson, we are looking at vertical asymptotes and horizontal asymptotes, but connecting them to the idea of limits. This is two different lessons that I'm combining into one video, so you can kind of see how they compare. So to start, I'm looking at the left at this vertical asymptote. So notice the vertical asymptote is at 1, so we're going to look at the limits as we approach 1. So as the graph is approaching 1 from the left, what are your y values approaching? It's approaching this direction. It's approaching negative infinity. But as you're approaching the vertical asymptote from the right, you can see the y values are approaching positive infinity. And then since the left and the right are not the same, the limit at 1 does not exist. Now, I don't want you to think that all limits approaching vertical asymptotes does not exist, because it's possible that both the left and the right will be approaching the same infinity. So now let's look at this horizontal asymptote. So here I have this horizontal asymptote at 2, but look at the limit. So I'm approaching infinity. So what are the y values approaching as the x values are approaching infinity? So as the x values are going towards positive infinity, the y values are approaching the horizontal asymptote of 2. And then same thing from the left. As you're approaching negative infinity, the y values are approaching 2. Now, approaching positive and negative infinity, just know that they don't always approach the same number, but in this case, they do. So kind of the big takeaway is when you're approaching a vertical asymptote, your answer, your y values, are positive infinity, negative infinity. But here, if you're approaching infinity, we're often looking for horizontal asymptotes. Okay, so in a previous lesson, we were finding vertical asymptotes, and we often are doing that by this factor cancel method. So this is referring to specific rational functions where we factor and cancel to find those vertical asymptotes. But now we actually have a limit approaching a function that has a vertical asymptote. So we can factor. Nothing's going to cancel in this example, but factoring can still be helpful. The denominator would factor to x plus 4, but I'm going to write it as x plus 4 squared. Okay, so to know if a limit exists at a value, we have to look at the left and the right. Well, what is happening at negative 4? If you look here, there is a vertical asymptote at x equals negative 4. So what is happening as we are approaching this vertical asymptote? So from the left and from the right, we're going to plug in numbers left and right of negative 4. So if I plug in a number left of negative 4, that's very, very close to negative 4, so here, and then I add 4, and then I square it. Squaring it guarantees that it's going to go positive, but I'm going to have this very tiny number. So 1 divided by, I just like to think about the sign. It's positive, and you're dividing by a very tiny number. So when you're dividing by a tiny number, it's approaching infinity. And in this case, it's approaching positive infinity. So let's check the direction that the y values approach when the x values approach negative 4 from the right. So if I plug in negative 3.999, same thing as above, I'm going to get a tiny number, and then I square it so it goes positive. So I have 1 over a positive, very tiny number. So this will also approach positive infinity. So notice how the left and the right approach the same. Therefore, this original question is positive infinity. Okay, so here is another example where we are going to approach a vertical asymptote. So this function right now is not super obvious what the vertical asymptote is, so we're going to do the factor and cancel. So when we factor the denominator, notice how we can cross these off. So there's a whole at -3, but that has nothing to do with what we're approaching. Where we're approaching, we can see, oh, that's at that vertical asymptote at x equals -5. So we're approaching a vertical asymptote. Okay, so now this is, from the start, a one-sided limit. So we only care about the one side. It doesn't have to approach the same from the left and the right. We're only testing the left. So let's plug in a number that is left of -5. So in this case, -5.001 is the left. So when we simplify this, we will have 1 over, and it will be a negative, and a negative small number. So this is going to approach -infinity. Okay, so moving on to horizontal asymptotes, but vertical asymptotes, when you approach the vertical asymptote, it's going to go towards infinity or -infinity as your answer. Okay, now we are reviewing how to find horizontal asymptotes specifying on rational functions. So this is review from last year, but we're going to take this knowledge and turn it into limit questions. So a rational function, we're looking at the power, the degree, in the numerator. So when do you have a higher degree in the numerator, a higher degree in the denominator, same degree, numerator and denominator. So here we have a rational function where we have a higher degree in the numerator than we do in the denominator. And this is asking, as x approaches infinity, this function approaches what y value? Well, in this case, when this degree is higher in the numerator, there is no horizontal asymptote. Because this, as x approaches infinity, y is also going to approach infinity. So the first example doesn't actually have a horizontal asymptote, and the answer is infinity. Okay, so now we have a higher degree in the denominator because this is degree 1. So when we have this scenario, we know that there's a horizontal asymptote at y equals 0. So as we're approaching infinity of this function, the y values are approaching 0, but then we have this plus 3, so that's like the function is shifted up 3. So 0 plus 3, this limit is actually equal to 3. And then when we have a rational function where the degree is the same, the horizontal asymptote is at those leading coefficients. So there's a horizontal asymptote at y equals 6 over 3, which is 2. So as your x values are approaching infinity, your y values are approaching the horizontal asymptote 2. These functions approaching horizontal asymptotes can get a little crazy and confusing, but we're going to practice all different types in class, especially when we're approaching a negative infinity. We'll be practicing those in class as well. But the last part of the video is looking at a few trig functions that have horizontal asymptotes. Okay, so here are 3 limits with trig functions, and one of them actually does not have a horizontal asymptote, and it's this first one. So if you think about cosine x, what does cosine x, as x values approach infinity, what do the y values approach? Well, it is oscillating between -1 and 1. It's not, going off here and approaching infinity or negative infinity. It's constantly oscillating. So this is actually does not exist. Okay, so let's look at this next one. These next two, they do have horizontal asymptotes. So as x approaches infinity of cosine over 1x. So off the top of your head, you might not know what that graph looks like, and that's fine. But I want you to envision, now it's bad math to write this. So cosine of 1 over infinity. You're not really supposed to plug infinity into a function because it is not a numerical value, but I like to do this just when I'm first explaining it so you have that visual. Dividing by infinity, dividing by a very, very large number, is like approaching 0. So what is cosine of 0? Cosine of 0 is 1. So this function actually has a horizontal asymptote of 1. So the limit as x approaches infinity, the y value approaches 1. And similar to the last example, if you think, okay, sine of infinity over infinity. So up here we talked about cosine. Well, cosine, as you're going to infinity, is going to oscillate between -1 to 1. And any of those numbers between -1 and 1, when you divide by infinity, very large number, it's going to be 0. So this actually has a horizontal asymptote at 0. Okay, there's a lot of information in this lesson. We're going to spend a few days on this in class to kind of go over all the details. But we've got limits approaching vertical asymptotes, and then limits approaching infinity, which equal horizontal asymptotes. Good luck with your lesson.